Okay, this is optional. It's, prove this identity over here. I do notice just looking at there's a mistake in this, and I will correct this. You're not going to see this in your notes, by the way. This should be written as the cosine of x over 2. So what I want to do is get a relationship between sine and cosine, something to do with, maybe double angle or half angle formulas. And probably the simplest one I could use this one over here. Right? This is one that's known to you. You know this. By the way, this was originally shown to be true by Euler. All right? So, one of two directions you can go in with this. You can go in, this way by keep doubling the angles, and you'll get this pattern over here. Or you can go in this direction over here, keep having the angles, and you get this relationship over here. And I want to say that this seems like the more likely path to me, because I do see the angle repeatedly being halved each time. So what I want to write down is what I'm seeing over here. So I'm here seeing the sine of theta over 2 to the n minus 1 over the sine, 2, sine theta over 2 to the n. And this is equal to cosine of theta over 2 to the n. All right, I just use this relationship over here. So this is an important relationship. Let me start erasing some of the distractions over here. Erase this distraction over here, this over here. I do want to emphasize there's an error again. Again, that error is going to be corrected. This should read as cosine x over 8. And you should realize the next one will be cosine x over 16. And this just goes on forever. All right? What I'm going to do is I got to look at a finite case first, though. So finite. And I'm going to say finite for me is going to be, some number n. And n is going to be bigger than 1. It's going to be an integer, by the way. And I'm going to use a notation not familiar with. It's a pi notation or product. Uppercase pi looks like this. I'm going to say n equals 1 off the big N. And I'm going to do the right-hand side first. So I'm just going to do this first. This is right-hand side. And what do you get there? This would be cosine of theta over 2n. Put this over here. I could expand this, by the way. What do you get? Cosine theta over 2, cosine theta over 4, yada, 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 all the way up to cosine of theta over 2 to the big N. All right? That sort of looks like this, but it's finite. Now let's do the left-hand side now. So what am I doing? I'm doing the product now, n equals 1 off to big N of sine theta over 2 to the n minus 1 over 2 sine theta over 2 to the little n. All right, let me see if I can do that. And to write that down, it's really not that bad. There's a top and a bottom to that. So the top in the product is going to be sine of theta, I'm starting at 1, times the cosine, I'm sorry, not cosine, sorry about that. Sine theta over 2, yada, 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 and where's it going to stop? At the sine of theta over 2 big N minus 1. What's the bottom going to look like? 2 times sine theta over 2. Now the next one's going to be another 2. So what do I start to realize? There's going to be n factors of 2. That's big N. Sine theta over 4 times yada, yada, yada. It goes up to some stopping value, and that's going to be sine of theta over 2 to the big N. What I'm going to do now is I'm going to look for cancellations, and I see some. This cancels. There'll be one here that cancels, and there's one here that also cancels. And you're left off with something pretty simple on the left-hand side. You're left off with, let's write this down carefully, sine of theta, whoops, my mistake. You're left off with the sine of theta on top, and on bottom you get 2 to the n. Right, let me just circle these guys here. That's the top, I can see this, and I see this. I'll write it down for you, and it's going to be sine of theta over 2 to the big N. And that big N is some finite n. all right? And what's that equal? It's equal to this thing over here. It's the same thing. But I don't want a finite case. I want the infinite case. And the infinite case is going to be when you let the big N go off to infinity. Now, I hope you realize if I let the big N go off to infinity, what's the right-hand side going to look like? It's going to look like cosine theta over 2 cosine theta over 4 times cosine theta over 8, yada, 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 yada. It goes on forever. But the left-hand side, a little more complicated. And I'll write it down for you. It's actually going to be a limit. And limit as the big N goes towards infinity. And I got to be careful here. It's going to be sine theta over 2 to the nth power times sine theta over 2 to the n. All right? So the problem with this is, I have to be honest with you, certainly is, I don't know what to do with this thing. It looks too difficult. It is. So we got to give you sort of like a hint over here. So when you take calculus, you're going to find these two limits over here are going to be quite useful. All right? And what does it say as x goes towards 0? Well, I'm not going towards, I'm going towards infinity. And it says, the sine of x over x, same thing as the limit as x goes 0 of x over sine of x, and it equals 1. And you could rewrite these guys here. I'll point out what I mean by that. I could write down the limit as x goes towards infinity. Well, in that case over there, you would get sine. Then it would be 1 over x, 1 over x. Or you could write this as limit x goes to infinity, 1 over x, sine 1 over x. It's really the same thing. It's 1, it's just 1. Now, I'm seeing short of that, but not really that. So what I need to do is write it down. I need to see that. And again, we're concentrating on this over here. So I'm gonna concentrate on that. So it's gonna be limit as n goes towards infinity. I'm gonna write down sine theta over theta. No, I don't see a theta there yet. But I'm gonna write this as, let's take a look at that. Times, let's write this down. This would be 1. No, I need a theta there, don't I? All right, let me just circle what I've done. I've done this. And that's about it. I'll write this over here. So what do you get? 2 to the n sine theta over 2 to the big N. All right, let's keep moving. Oh, boy. Let's take a look at this. It has nothing to do with this, by the way. So I'm going to just say there's nothing to do with that. Again, I want to focus in on something. I'm trying to see these things over here. And this has to do with the letter N now. And let me write this down. It looks like this over here. So I'm going to, rewrite this a little differently. I'm going to write it as theta over 2 to the n, and then sine theta over 2 to the n. I'm seeing it. I am definitely seeing it. And what's that going to be? This limit is very easy. It's sine theta over theta. So what have I shown? I've shown this, which is the same thing they wanted me to show. So it's a QED at this point. All right, we got this. We're done. QED. Thank you.